Have you ever pondered upon the enigma of time travel and wondered if it could ever be a reality? As humans, we've always been fascinated by the concept of time travel. The idea of zipping forward to see the future or cruising back to revisit the past has captured our collective imagination for centuries. It's a staple of science fiction and a beloved trope in popular culture, from H.G. Wells' iconic Time Machine to the wildly popular Back to the Future series. But beyond the realms of fiction, is time travel even a possibility? Could we, mere mortals, ever hope to conquer the seemingly unyielding flow of time? It's a question that has perplexed great minds and intrigued curious souls. And while it may seem like a concept firmly rooted in the fantastical, the answer might lie closer to reality than we think. Enter the world of Albert Einstein, the man who dared to redefine our understanding of the cosmos. Einstein's theory of special relativity, formulated in the early 20th century, introduced a radically new perspective on time. It proposed that time is not absolute, but relative and flexible. It flows differently for objects moving at varying speeds. The faster you move through space, the slower you move through time. This phenomenon, known as time dilation, suggests that time travel, at least to the future, might not be so far-fetched after all. But while the concept of time dilation may seem abstract and hard to grasp, it's not just theoretical. It's been proven through rigorous experimentation, using precise atomic clocks and high-speed travel. It's a testament to the power of human ingenuity and the boundless possibilities of the universe. So are we on the brink of unlocking the secrets of time itself? Can we truly hop into a time machine and zoom off to unseen eras? Well, only time will tell. But one thing's for sure. Einstein's theory of relativity may hold the key to unraveling this mystery. Albert Einstein, one of the greatest minds of the 20th century, proposed a theory that forever changed our understanding of time and space. Let's dive into the world of Einstein's theory of special relativity. This theory is a game changer. It tells us that time is not rigid and unchanging, but rather, it's flexible and relative. This means that time does not tick away at the same speed for everyone and everything. It's a bit like the soundtrack to a movie that slows down and speeds up depending on the scene. Now, let's talk about time dilation and length contraction, two mind-boggling concepts that are at the heart of Einstein's theory. Imagine you're on a spaceship zooming through the cosmos at near light speed. According to the theory of special relativity, time would actually pass slower for you than for someone standing still on Earth. This is known as time dilation, but that's not all. As you speed up, your spaceship would also appear to contract or shorten in the direction you're moving. This is what we call length contraction. So, in essence, the faster you move through space, the slower you move through time, and the shorter you appear to an observer at rest. These are not just theoretical concepts. They have been proven through numerous experiments, including those using ultra-precise atomic clocks. When these clocks are flown around the world and then compared to stationary ones, the moving clocks are found to have ticked slower. Yes, you heard it right. Time really does slow down when you're moving fast. Einstein's theory of special relativity is not just a cornerstone of modern physics, but it also opens up fascinating possibilities for understanding the universe and even the concept of time travel to the future. In the realm of the super-fast, time slows down and distances shrink. This is not science fiction, but the fascinating reality of our universe as revealed by Einstein. If we could travel at near light speeds, would we age slower than those left behind on Earth? This tantalizing question taps into the concept of time dilation, a key part of Einstein's theory of special relativity. Time dilation is the idea that time isn't a constant, fixed entity. It's flexible, bending and stretching with the fabric of the universe. According to Einstein's theory, time passes slower for objects moving at high speeds relative to others. This isn't just a theoretical concept. It's been proven with real-world experiments involving atomic clocks. Let's delve into one such experiment. Two atomic clocks were synchronized. One was kept stationary on Earth while the other was sent on a high-speed journey in a plane. According to the theory, the clock in motion should tick slower than the stationary one, and guess what? When the airborne clock returned, it had indeed recorded less time than its stationary counterpart. This confirmed that time had slowed down for the moving clock, demonstrating time dilation in action. So, what does this mean for the idea of time travel to the future? Well, it suggests it's entirely possible, at least according to relativity. If you were to embark on a journey traveling near the speed of light, time would pass slower for you than for those left behind. You'd age at a slower rate, effectively leaping into the future when you return to a world that had aged faster than you. This might sound like the stuff of science fiction, but remember, this isn't just theoretical. It's grounded in experimental evidence and rigorous scientific theory. It's a mind-bending concept challenging our everyday understanding of time. But then again, the universe is full of such wonders, isn't it? The faster we move through space, the slower we move through time. So buckle up, future time travelers. The journey ahead is going to be a fascinating one. But what about traveling to the past? Could we ever rewind the clock and revisit earlier times? A question often asked, and the answer lies within the intricate world of Einstein's theory of relativity. According to this theory, time is not a constant stream, but rather a flexible dimension intertwined with space. It's a concept that's as fascinating as it is complex. But here's the kicker. While the theory allows the possibility of time dilation or traveling to the future, it doesn't quite extend the same courtesy to the past. Why is that? Well, let's delve into the world of paradoxes and contradictions that would arise if such a journey were possible. Imagine, if you will, a scenario where you could travel back in time and meet your younger self. Sounds exciting, right? But consider this. What if you were to prevent your younger self from making the time machine that allowed you to travel back in time in the first place? This is what's known as a grandfather paradox, a contradiction that defies the very laws of cause and effect, creating a loop that can't be resolved. And it doesn't stop there. If time travel to the past were possible, it would imply that the future is predestined, that every choice we make has already been decided. This would contradict the concept of free will, which is fundamental to our understanding of the universe and ourselves. Moreover, Einstein's theory of relativity involves not just time, but also space. To travel back in time, one would need to move faster than light, a feat that, as far as we know, is beyond the realms of possibility. The energy required would be infinite, and the length contraction would render the traveler non-existent. In the fascinating world of theoretical physics, where time and space bend and twist in ways we can barely comprehend, it seems that the past remains firmly out of reach. Time, it appears, insists on moving in one direction only, forward. As appealing as it may be, a trip to the past remains a fantasy confined to the realms of fiction. Even if we can't go back in time, the possibility of future time travel opens up a universe of fascinating prospects. Imagine, if you will, a world where time is as flexible as a rubber band. This is a world where we can leap forward in time, experiencing the thrill of the unknown, the lure of the future. Just think about the benefits of such a possibility. We could witness the evolution of technology, the rise and fall of civilizations, the unfolding of human history in real time. Imagine being able to explore the cosmos at high speeds, effectively slowing down your own time and returning to an Earth that is centuries ahead. The secrets of the universe, the answer to the question of life, the universe and everything, could be in our grasp. However, let's not get ahead of ourselves. With great power comes great responsibility, and the power to traverse time is no exception. The future, after all, is a delicate tapestry, woven from the threads of decisions made in the present. Any disturbance could have far-reaching consequences. We must tread lightly and respect the sanctity of time. Furthermore, there are the practical challenges to consider. Achieving the speeds necessary for significant time dilation is currently beyond our technological capabilities. The energy requirements are enormous, the dangers considerable. But as we've learned from Einstein, nothing is impossible. It's a matter of understanding, of discovery, of pushing the boundaries of what we know. So let's continue to explore, to learn, to question. Let's delve deeper into the mysteries of the universe, into the fabric of time itself. Let's dream of a future where the stars are within our reach, where time is our playground. Let's dream of a future where time travel is not just a fascinating possibility, but a tangible reality. The future of time travel, much like time itself, remains a tantalizing mystery waiting to be unraveled.